Today we will see the content of instrumentation and process control engineering. This is one of the best subject in food technology. We will see in that which topic we are going to cover. In that we are going to cover temperature as a vibrant process variable. Okay. First we will see what is meant by temperature. The definition of temperature is by the book of instrumentation which is written by Crick and Rimbaud. Temperature is defined as the degree of hotness and coldness of any material, which is called as a temperature. Okay. In that, this is one of the topic of instrumentation and process control engineering. Which topic we are going to cover under that? General theory on temperature and heat transfer. Next is that temperature scales. There are various types of scales such as Fahrenheit, centigrade, Kelvin and Rankine and international temperature scale. Okay. Next thing is that methods to measure the temperature. By which various methods we are measuring the temperature of commodity, which includes expansion thermometer, pressure spring thermometer, electrical temperature instruments and pyrometer. We will see one by one this content. Introduction. There are three modes of heat transfer. Heat transfer, which is transferring from higher temperature to the lower temperature. Okay. There are three modes which is called as convection, conduction and radiation. Okay. We will see one by one. When we can say this is conduction, when we can say this is convection, when we can say this is the radiation. Here one small example is given. By seeing this example, you will get it how these three modes of transfer will happens. First one, convection, the transfer of heat through a fluid, which may be liquid or gas caused by molecular motion. Okay. The molecules, those are adjacent to each other. One molecule is heated. He got the heat and he will transfer heat to the adjacent molecule. Then we can say heat has been conducted. This is the best example of conduction, which includes molecular motion. Next thing is that conduction. The transfer of heat or electric current from one substance to the another by direct one. This is called as a conduction. Now next, convection means the transfer of heat through fluid caused by molecular motion. Okay. We are giving the heat to the utensils and that utensil will transfer heat to the molecules. At that time we can say heat has been convected. The next thing is that radiation. Energy that is radiated or transmitted in the form of rays or waves or particles. Heat is transferred through the hot rays, which is called as a radiation. This is the indirect type of heat transfer. Okay. Did you understood? There are three modes of heat transfer: conduction, convection and radiation. This is the best example combinedly for the modes of heat transfer. Scales. There are various types of scales are used for measuring the temperature. We will see one by one. Temperature is measure of the thermal energy in the body. Normally measured in degrees using one of the following scale. There are four types of scale. Those are used for measuring the temperature. First one is a Fahrenheit. Second one is a Celsius, which is also called as centigrade. Third one is a Kelvin. Fourth one is a Rankine. These are the four types of scales. Those are used for measuring the temperature. Here temperature scales comparison is given. How these all scales are comparative. Then we will see when Fahrenheit scale is there. We are comparing with the Celsius, we are comparing with the Kelvin. At the bottom, when absolute zero temperature is there of Fahrenheit, at that time minus 273 degrees Celsius will be there for the temperature scale. At the same point, 0 Kelvin will be there in the Kelvin scale. This is the comparison of various scale at one platform. Second thing is that suppose 32 degree Fahrenheit is there, at the same time 0 degree Celsius will be there, and the same time 273.15 Kelvin will be there. At the same time we are comparing these three scales, means boiling point of water. At one point we are taking the three scales of one commodity. 100 degrees Celsius, and which will be comparative to 212 degree Fahrenheit and 373.15 Kelvin. These are the comparison of various scale of temperature for one commodity for one platform. Temperature conversion formulas. There are various formulas has been established for conversion of various scales. We will see one by one. Celsius to Fahrenheit, Kelvin to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Fahrenheit to Kelvin, Rankine to Celsius, Rankine to Fahrenheit, Rankine to Kelvin. Why these scales are required? There are various international scales. Various commodities is measured by various scales. For that purpose, suppose we want to bring all the scales at one platform, all the degrees at one platform. For that purpose, these conversion formulas are useful. Okay, we'll see one by one. Celsius to Fahrenheit. For that purpose, formula is 9 by 5 degrees Celsius plus 32, which will convert Celsius to Fahrenheit. Second thing, Kelvin to Fahrenheit. 9 by 5 in bracket Kelvin minus 273 plus 32, which will give you a degree Fahrenheit. Fahrenheit to Celsius. 5 by 9 in bracket degree Fahrenheit minus 32, which will give you scale in Celsius. Celsius to Kelvin. Degree Celsius plus 273, which will give you in the Kelvin form. Then Fahrenheit to Kelvin. 5 by 9 in bracket degree Fahrenheit minus 32 plus 273, which will give you Fahrenheit to Kelvin. Next thing, Rankine to Celsius. Celsius is equal to Rankine minus 32 minus 459.67 divided by 1.8, which will give you Rankine to Celsius. Next one, Rankine to Fahrenheit. Fahrenheit is equal to Rankine minus 459.67. Last one, Rankine to Kelvin. But it will give Kelvin is equal to Rankine scale divided by 1.8, which will give you Rankine to Kelvin. These are the various formulas used for temperature conversion. You can solve various examples for temperature conversion. I have given, this is for your assignments. You can use previous formulas for conversion of temperature scales. First question is that Celsius to Fahrenheit. I have given the example 52, B 47, C 81. These are the units. Second one, Kelvin to Fahrenheit, 23, 61, 76. Third question, Rankine to Celsius, 16, 96, 66. And last one, Fahrenheit to Celsius, 44, 25, 72. These are the examples you can solve at your home by using previous slides formulas. These are the temperature conversion examples. Temperature measuring instruments. Next topic is that temperature measuring instruments. First we will see mercury or liquid in a glass thermometer. Mercury thermometer or liquid in a glass thermometer. We can say in both way. Okay. At this end, image is there. Okay. Which will be having three sections. First we will see the construction. In that scale, that equipment, instrument will be having three sections. bulb, stem and scale. Okay, you can see there, scale is there, whole glass stem is there, mercury which is at the bottom. Okay, first we will see bulb. Where is the bulb? The reservoir for containing most of the thermometric liquid, they have taken the mercury. Means these are thermometric, sensitive to the temperature. Once they will receive the temperature, they will absorb the temperature, they will rise it, they will increase their temperature, degree of hotness or coldness. Second thing is that stem, the glass tube having a capillary bore along which the liquid moves with the changes in temperature. Once the temperature which is absorbed by the bottom which contain mercury which is called as bulb. Okay, once they will receive the temperature, it will rise in the stem. Last one, scale, a narrow temperature range scale for reading a reference temperature. Scale is given, scale is formulated, scale is standardized. When some quantity of temperature is absorbed by the thermometer, proportionately it will increase the mercury in the stem. Okay, this is one of the temperature measuring instrument which is called as a mercury or liquid in a glass thermometer. Next slide indicates the volume of mercury changes slightly with temperature. The small change in the volume drives narrow mercury column relatively a long way up the tube. Okay, what it indicates, when they will absorb the temperature, which is degree of hotness or coldness, they will absorb slightly, they will move it slightly. When they will absorb something, they will proportionately move in the stem. The space above the mercury may be filled with nitrogen or it may be at less than atmospheric pressure, which is a partial vacuum. The reason is that we should get accurate temperature which is measured by the thermometer. If we are adding some another gases in the vacuum, what will happen? They will affect on the temperature reading. That's why it is standardized to get the nitrogen or any other form which having less than atmospheric pressure. Every equipments, every instrument will be having advantages and disadvantages. The reason is that when we can say this is having advantage, when we can say this is having advantage, we are targeting some specific features. For that purpose, suppose we are getting our targets as per the previous conclusion, then we can say these are the advantages. If our target is not achieving, at that time we can say this equipment will be having some disadvantages, like that. Simplicity in use and low cost. The thermometer, anybody can use it, which is very simple to use and having very low cost. Suppose a small entrepreneur wants to calculate their product with various parameters and temperature is one of them, he can afford it because it is having very low cost and simple in use. Portable device. You can carry the thermometer anywhere. Suppose you want to go from one place to the another place, your land is there, your processing center is there, your some sections are there. At that time, you can carry this device. Checking physical damage is easy. Thermometer, by your own, you can see is the equipment is working properly or not. Is it okay or not? Is it in good condition or not? Last one, power source is not required. Suppose summer season is there. In summer season, what used to happen? Sometimes electricity will go. At that time, what you used to do? You can use this type of thermometers. It does not require power source. Suppose any commodity, any equipment which is depend on the power, then if power is not there, we cannot apply it, we cannot use it. That's why these are the various advantages of liquid in a glass thermometer. Few disadvantages: cannot be used for automatic recording. Automatic recording is not possible with the this type of thermometer. Time lag in measurement. And lastly, it ranges in limited to about 300 degrees Celsius. It is having some range. It cannot read beyond that. Some processing operations will be having higher temperature. At that time, we want to measure the temperature by using this thermometer, which is practically not possible by using this type of thermometer. Next one, bimetallic thermometer. What it indicates, in an industry there is always a need to measure and monitor temperature of a partial spot, field or locality. There are various sections at that point we have to measure the temperature. At that point, bimetallic thermometer is most useful. The industrial names given such as temperature indicators, temperature gauges, these are most important. If your employees don't know which equipment is called what, then they are unable to detect the perfect parameter for particular commodity. All these temperature gauges belong to the class of instrument that are known as bimetallic sensors. Next, there are two basic principles. Okay, the metal tends to undergo a volumetric dimensional change, which is called as expansion or contraction according to the change in temperature. Once that equipment will gain the temperature, it will get expand. When they will lose the temperature, it will get contract. Different metals have different coefficient of temperatures. The rate of volumetric change depends on this coefficient of temperatures. You can see in the figure, this is called as a bimetallic thermometer. One end is fixed, second one is free end. Bimetallic, two metal strips are there. Low expansion coefficient, high expansion coefficient. That second strip indicates that when they will gain the temperature, they are going to expand it. When will cool down, they will lose the temperature, then again it will come to its original position, that is contraction. The device consists of a bimetallic strip of two different metals. As earlier I have told you, they are bonded together to form a spiral or twisted helix. Both these metals are joined together at one end by either welding or riveting. It is bonded so strong that there will not be any relative motion between the two. When you are going to measure the temperature, that bonding should be strong. Otherwise, what will happen? It will not read particular temperature accurately. There will be error. Advantages and disadvantages. What it indicates? Let's see. Power source not required, which is also similar to the previous thermometer. Robust, easy to use and cheap. Next one, can be used to 500 degrees Celsius. Earlier thermometer which is having range up to 300 degrees Celsius. You can use beyond that. Suppose you want to read the temperature about 400 degrees Celsius, you can use bimetallic thermometer. Disadvantages: not very accurate, limited to applications where manual reading is acceptable, not suitable for very low temperature because the expansion of metal tends to be similar, so that device becomes a rather insensitive thermometer. The thing is that suppose you want to measure the temperature at particular point which is very low, and for expansion of that metals required little bit more temperature. At that point you cannot use type of thermometer. So this is the various thermometers are used for measuring the temperature for particular process. Thank you.